Next, NASA says its Voyager 1 probe, the most distant human-made object in the universe.
It drifted past Saturn's rings and Jupiter's storms. It whispered through the silence of interstellar space. But Voyager's greatest message was not its postcard from Neptune, nor its golden record spinning into forever. No. What it delivered, quietly, almost shyly, was a weather map. Not of Earth or Mars, but of something stranger. An invisible barrier. The heliosphere. And for decades, NASA almost missed the point. What if Voyager's most stunning discovery was not a planet, but the shape of a storm we were never taught to see? The mission refuses to die. Thruster revival. For most of us, a machine left untouched for 20 years is a relic, an artifact maybe. To some, it's a story that is frozen in time, but aboard a spacecraft over 15 billion miles from Earth, something long dormant stirred. On the edge of interstellar silence, NASA engineers issued a command, not to collect data or to adjust instruments, but to try something no one expected to work. They asked Voyager 1 to breathe life into its backup thrusters. These weren't just metal cylinders strapped to the chassis. They were lifelines, gatekeepers of orientation. In other words, the only tools capable of nudging Voyager ever so slightly, just enough to keep its antenna pointed toward home. The main thrusters had been losing grip. With every adjustment, they required more energy to produce the same effect, like a tired dancer missing beats in a ballet choreographed across the cosmos. The shift was subtle but dangerous, because in space, the difference between mission control and oblivion is just a few degrees off. NASA's Jet Propulsion Lab knew this moment would come, but not like this. Not under the pressure of a looming communications pause that could leave Voyager adrift for months, if not forever. Then came the decision, a risk that balanced the weight of 46 years of cosmic history. They turned to the trajectory correction maneuver thrusters, the ones last used in 2004. That's right, 2 decades of silence and cold. Imagine it, a signal traveling over 22 light hours away, sent to a spacecraft built when rotary phones were still in style, asking it to wake something ancient within its bones. And Voyager answered. On May the 14th, 2025, the backup thrusters fired. The old cylinders hissed back into action, their whispering puffs of hydrazine gently pivoting the spacecraft, just enough to restore proper orientation. The antenna held its line, and the data flowed. What stunned engineers was not just that it worked, it was how precisely it worked. No delay, no drift, or error. After 20 years, the response was as crisp as if they had fired yesterday. SciTech Daily called it just in time. Because it was, had NASA waited even by weeks, it might have been too late. The upcoming pause in communications meant the spacecraft needed to hold its attitude on its own. With these thrusters active, that was finally possible. Inside mission control, some reached for the lucky peanuts. A tradition born in crisis continued in reverence. But make no mistake, this was not luck. This was a legacy, a spacecraft forged in the analog age, maintained through the digital revolution, and still capable of answering when its creators came calling. CNN's headline focused on the miracle, but beneath the drama, a quieter question emerged. But what exactly is Voyager still sending us? And why did NASA go to such lengths to preserve the signal and ensure it remains uninterrupted? Because here is what most outlets missed. This was not just a maneuver to save a mission, it was a maneuver to save a message. Every burst from those revived thrusters was a vote of confidence, not nostalgia. But there is the possibility that Voyager, our silent scout beyond the solar winds, could still hold something worth hearing. Could you believe a spacecraft that far away could be nudged back to life? As the thrusters settle and the antenna locks its gaze, the question turns inward. What data did NASA prioritize now that power is precious and every watt must be weighed? Because keeping Voyager alive was only half the story. The real secret might lie in what it was allowed to say, or not to say. Power plays, hidden data pipeline. They called it a power-saving maneuver, but behind that sterile phrasing lived something far more tactical. At 15 billion miles from Earth, Voyager's nuclear heart was dimming, yet somehow the spacecraft kept whispering, not just functioning, but delivering secrets. And those secrets only reached us because someone at NASA knew how to play the long game. Most people imagine space missions as a countdown to silence. Fuel runs dry, batteries fade, and systems shut down. The end, right? But Voyager was never built to just coast into darkness. It was designed to think in decades, not days, to ration power like a candle in a storm. The secret was RTG, radioisotope thermoelectric generators. Inside these nuclear batteries, plutonium-238 decayed slowly, releasing heat. That heat became electricity, a quiet, constant current that kept Voyager's instruments warm and talking. But by 2023, those batteries were old bones. Power had dropped below 50%, and every subsystem, every camera, detector, and transmitter was a hungry mouth. So NASA made a ruthless choice. They shut down instruments, not permanently, but in a sequence, a ballet of silence. One system at a time, powered off, then back on. Others left dormant. Imagine dimming lights in a grand library, not because the knowledge is gone, but to keep the reading room open just a little longer. This was not just engineering, it was triage. One maneuver pulled power from a backup circuit designed for onboard thruster protection, a failsafe, dormant for decades. By rerouting that power, NASA bought Voyager months, maybe years, of additional signal time. And although they gambled, it worked. But here's where it gets interesting. The instruments they chose to keep alive were not just for basic telemetry. These were sensors aimed outward, far beyond the heliopause, into the interstellar dark. Instruments that, for decades, had been dismissed as low priority. We're talking about magnetometers, cosmic ray detectors, and plasma wave subsystems. Data that trickled in quietly, without headlines. Why prioritize those? Because Voyager, now outside the sun's protective bubble, was touching raw interstellar space. The kind of data that does not just inform, it rewrites. Pressure fields, particle densities, and unknown wave signatures are the clues, not about planets, but about the shape of our galactic neighborhood itself. Yet much of it went overlooked, buried in databases, untagged, uncelebrated. But why? Because NASA, like any institution, has optics to manage. Launches are sexy, I know, and landings get press every time. But particle flux data from deep space, that lives in footnotes. Still, someone made the call. Kill the camera, save the cosmic ears. And for years, those ears recorded what no eye could see. Now, ask yourself, if you had to choose between the beauty of an image and the truth of an invisible storm, what would you keep? Because NASA chose the storm, and by doing so, it created a pipeline of forgotten data that is only now being decoded. It was not just a technical maneuver, it was a philosophical one. While engineers extended the ship's life with a few clever powers rerouted, they also kept something far more fragile alive. But if power keeps Voyager alive, who decides what lives in science? Yes, engineering saved the ship, but what about the knowledge everyone focused on while the real treasure stayed silent? Planetary starlight, moons that stole the show. The planets were the spectacle. Jupiter with its swirling storms, Saturn with its rings etched like golden vinyl. That is where all eyes went, where the headlines pointed. But Voyager, always the quiet observer, saw something else entirely. It peered past the giants and the obvious, and what it uncovered was nothing short of mutiny. Take Enceladus, for instance, a small icy orb nestled around Saturn, long dismissed as inert and unremarkable. Voyager's cameras rolled past it in 1980. What they captured defied every rule in the geologic playbook. On it, there were plumes, actual geysers erupting from beneath its crust, cryovolcanic jets spewing water vapor and ice, painting its southern hemisphere with ghost white fractures. Beneath that frozen shell, something stirred. This was not a dead world, rather it was breathing, and it had just whispered its first breath to us. Then came Titan, more famous perhaps, but less understood. Before Voyager, scientists believed it might be a barren satellite cloaked in smog. What they got instead was a world with rivers and lakes of methane. The surface, a hydrocarbon heaven, shimmered with oily smoothness. Voyager could not pierce the thick haze fully, but what it did glimpse was revolutionary. Titan was not just cold, it was chemically active. Its dense and dynamic atmosphere resembled a prehistoric Earth before the first breath of oxygen, a time capsule, to say the least. One is soaked not in water, but in the potential for prebiotic chemistry, the kind that makes you ask, how far is too far to rule out life? This was the great betrayal. We had gone looking for gods among planets, but the stories that endured were written on their moons. Io, a tortured child of Jupiter's gravity, erupted with molten sulfur as Voyager passed by. It was the first confirmation of active volcanism beyond Earth. Not a single eruption, but dozens. An entire body reshaped in real time, caught red-handed mid-creation. The kind of geologic drama textbooks had been reserved for early Earth or fantasy fiction. And yet, despite these revelations, the moons never got their spotlight. They were treated like side notes, supporting actors to planetary leads. But Voyager knew better. Its data whispered of subsurface oceans and thermal plumes, of alien weather and underground seas. These moons were not leftovers. They were contenders. In Titan's smog, we saw our origins. In Enceladus's geysers, we saw the ghost of life's possibility. These silent revolutionaries are still there now, circling their giants like secrets, waiting, daring us to return. Perhaps the next Voyager will not just pass by, but listen closer. Which moon's secret would you most want to explore? The methane-soaked stillness of Titan, or the icy breath of Enceladus pulsing from its southern pole? But even these moon revelations pale next to what lay beyond our solar frontier, where Voyager's final message stirred questions that NASA still has not fully answered. Crossing the cosmic barrier, the forgotten heliosphere. It did not arrive with fireworks or trumpets, no blinking dashboard or triumphant countdown, not even a camera swivel to reveal Earth shrinking behind it. Voyager's most significant moment, its real triumph, was almost silent. In 2012, after 35 years of drifting outward, Voyager 1 slipped across a threshold humanity had never touched. A threshold older than planets and colder than physics textbooks had prepared us for. It crossed the heliopause, the place where the sun's influence ends and the deep unknown begins. But what it encountered on the other side was far more than just calm. It was chaos. A sudden spike, not of light, but of plasma. The probe's battered but functional instruments detected something no telescope on Earth had ever seen. The density of charged particles multiplied dramatically, from sparse solar breezes to something altogether alien. Like surfacing into a storm, only this was not weather. It was the interstellar wind, galactic space, a realm not shaped by the sun, but by the cosmos beyond. And it was not alone. 6 years later, Voyager 2 made the same crossing, same symptoms, same shock. In 2018, it registered a near instantaneous rise in plasma density as it breached the heliopause. This was no fluke. It was confirmation that the edge of our solar system was not a gentle fade, but a border, a barrier of sorts. A wall of energy and pressure is more volatile than expected, yet almost no one noticed. When they mentioned it, the media called it a scientific milestone, but few explained what it meant. Even fewer lingered on the details. Voyager revealed that the heliosphere, the sun's magnetic bubble, was not static. It was breathing, pulsing, warping under galactic forces we barely understood. Cosmic rays, the high-energy particles from outside the solar system, surged as the probes passed through. Imagine that. Like opening a door and being hit by wind from another universe. Not metaphorically, but literally. The shock was not just in the data, it was in what the data suggested, that our solar system is not an island. It is a vessel drifting through unknown seas. And those seas have waves, tides, and storms. NASA's scientists were stunned, but the public barely heard about it. In the years that followed, research papers quietly shifted focus. From planetary flybys to space weather, from gravitational slingshots to galactic shielding, the heliopause was no longer seen as a line in the sand. It was dynamic, a cosmic shoreline where two great forces meet, the solar wind and everything else. But why did no one make a bigger deal of it? Why did Voyager's grandest discovery fade into the background? Maybe because it was not visual. There were no photographs, no color-saturated gas giants, just graphs, particle counts, and density spikes that looked like heartbeats of the void. And so they were archived, catalogued, and left for the niche journals and postdoc conferences. Yet these were not mere technicalities, they were omens. Because if the heliosphere shifts, so does Earth's protection. The magnetic veil that guards us from the worst cosmic radiation is not fixed. It breathes with the galaxy. What Voyager found was not just distance, it was vulnerability. And none of us had a plan. How would you prepare for a storm millions of miles wide? What if it had already begun? We tend to think of space as still, but space is a current. And Voyager, still silent, loyal, and drifting, was our first ship to pierce the tide and return with word. And with that crossing, Voyager became the first cosmic weather satellite. And the storm it found might already be changing the forecast. Cosmic Weather Satellite, mapping the sun's bubble. Yes, Voyager charted the first ever weather map of our sun's heliospheric shield, but this was no ordinary forecast. There were no gentle breezes or passing clouds in its path. In eerie silence and sheer durability, Voyager uncovered a kind of celestial turbulence that breathes, pulses, and mutates at the edge of everything we know. And for years, no one paid attention. The term cosmic weather may sound poetic, even fanciful, yet the science behind it is violently real. Surrounding our solar system is a vast, shifting force field, the heliosphere. It stretches outward like a bubble blown from the breath of the sun, shielding us from interstellar radiation. Voyager did not just pass through it, it listened, measured, and mapped the response. When Voyager 1 crossed the heliopause in 2012, and Voyager 2 followed in 2018, NASA described the moment as a kind of awakening. Both probes registered sudden spikes in cosmic ray intensity and abrupt drops in solar particle flow. Plasma densities shifted like crashing waves, revealing not a fixed wall, but a membrane, one that breathes. It's like a border in motion. This was not the edge of space. It was the front line of a weather system, cosmic in scale, magnetic in structure, and volatile in mood. For the first time in human history, we had charted its outline. What Voyager was doing, quietly and relentlessly, was building a cartography of the sun's shield, not with photographs or rock samples, but with readings that revealed how space bends and flexes under solar command. Magnetometers traced the twisting fields. Plasma instruments felt the density changes ripple across instruments. Cosmic ray counters tallied bursts of galactic energy trying to pierce through. Our solar system is not floating in calm waters. It sails within a moving tide, guided by solar winds and wrapped inside a bubble that bristles with electric storms. And this churning edge was the terrain Voyager first mapped. In truth, Voyager may be less of a planetary scout and more of a primordial weather satellite, a monitor for future travelers. A sentinel whispered, "Hear the winds rage, the boundary cracks, and the stars begin to pull." This reframing is rarely mentioned. It hides in plain sight among headlines of planetary flybys and golden records. But perhaps its greatest deliverable was not Jupiter's storms or Saturn's rings. It was the realization that our solar home has borders that are flexible, dynamic, and charged with danger. NASA's 2025 Voyager mission overview now quietly echoes this legacy. In the footnotes and the graphs, in the animations that flicker with years of plotted plasma densities, we see the first weather maps of the heliosphere, and not a single warning label in sight. If this map existed in real time, why did it take so long to recognize its power? Why were these measurements left to gather digital dust while the world focused on postcard planets? Well, because cosmic weather does not dazzle. It does not pose with rings or erupt in volcanoes. It whispers in particles and shifts in magnetic currents. It reveals itself only to the patient, but still, Voyager saw it, documented it, and survived it. And now we stand at the edge of knowing. So, what forecast would you print if you were charting a path to Alpha Centauri? What danger zones would you mark? Because out there, just beyond the bubble, storms wait. And Voyager has already told us where they begin. But if NASA saw this map in real time, why did it stay in the shadows? NASA's Sleeper Discovery, Reaction and Rumors. The silence was not accidental. Buried in the dim corners of internal memos, somewhere between budget lines and launch summaries, lay references to a peculiar anomaly, cosmic weather patterns just beyond the heliosphere. The data was there. The timestamps confirmed it. But while the world gazed at rocket launches and surface rovers, Voyager had quietly delivered something else. Something ignored. Officially, the Jet Propulsion Laboratory had flagged the shift. A set of magnetic fluctuations, barely a ripple to the casual observer, hinted at a strange interstellar boundary behaving more like a living membrane than a fixed wall. But instead of broadcasting urgency, the findings were tucked inside technical updates, surrounded by language sterile enough to sedate curiosity. No press conference, no countdown timer, it just filed. So, where did the story actually break? Not through a NASA press release, but through Reddit. Of course, somewhere in the basement depths of Reddit, users began connecting dots no one else had. Voyager just left the bubble, one post read. Another, more cryptic. It's not space out there, it's pressure. Threads spiraled. Charts were posted and theories followed. One user claimed NASA's silence pointed to a classified discovery. Another insisted the changes in particle density proved that Voyager had crossed into a zone of external influence, perhaps a cosmic tide beyond comprehension. But speculation is a shapeshifter. It wears the face of curiosity and the cloak of certainty. That tension gave rise to a homemade documentary's now viral video. It pulled viewers into a thriller but left them wading through gaps. The footage drew heavily from public NASA science pages. It referenced a 2012 transition event and the ongoing flow of interstellar plasma. But as the narrative deepened, it leaned harder on Reddit conjecture than peer-reviewed physics. Phrases like possible evidence and some believe dotted the second half, providing just enough ambiguity to sound profound. Yet, it is never quite grounded in the source. That is where the contrast stings. On one side, NASA, with its cautious cadence and carefully reviewed statements, a wall of scientists who will not say discovery unless it passes peer review and international scrutiny. On the other hand, Reddit sleuths, anonymous avatars, and documentary channels have a gift for dramatizing fragments. Still, the heart of the question remains. Why the delay? Some believe it was bureaucratic triage. When missions are stretched across decades, attention spans shorten. Others whisper something deeper, that NASA was buying time, not to suppress but to understand. The magnetic shifts, the plasma oscillations, the way Voyager's instruments responded not with decay, but rhythm. There is no firm proof that NASA downplayed the data intentionally, but even their own timeline betrays a lag. The raw findings appeared years before they gained traction outside internal circles, and when questioned, spokespeople danced. They used words like complex, unresolved, and still under review. So we ask, do you believe they hesitated for clarity or control? Were we watching a scientific process unfold slowly, or a masterclass in subtle redirection? Let us know what you think. Was this oversight or orchestration? Because while Reddit stirred and homemade documentaries teased, Voyager kept moving outward, unrelenting past equations and expectations. And as whispers grew louder, Voyager's legacy reached beyond the scientists into the minds of those who still look up at night and wonder what was left unsaid. Legacy and future missions. Voyager's journey isn't over. It is only the beginning of our cosmic weather reports. Long after the planetary portraits were snapped and the golden records drifted into myth, Voyager kept whispering. Through the darkness, across a solar system boundary no human hand had ever touched. What came back was not just data, but a revelation. a weather map of interstellar winds, magnetic tides, and solar breath carved across space itself. It was the kind of message governments file under future use. And now, decades later, that future has arrived. Designers of tomorrow's interstellar missions now study Voyager's late transmissions like sailors once studied ancient star charts. In the vastness beyond the heliopause, a new ocean begins. And with all its aged circuitry, Voyager became our first scout on those alien tides. What it found has been quietly shaping how we think about the next great leap. The heliosphere was once only a theory, a colossal, invisible shield inflated by the solar wind. Voyager made it real. When Voyager 1 pierced that boundary in 2012 and Voyager 2 followed in 2018, scientists expected a neat transition. Instead, they found a turbulent frontier. Charged particles deflected strangely. The solar wind halted, but beyond it, interstellar plasma pulsed in unexpected rhythms. It was not silent, it was a new kind of storm, and this storm matters. Any probe launched beyond the solar system must navigate more than the emptiness. It must endure currents of cosmic radiation, magnetic crosswinds, echoes from the sun's breath still rippling outward. Voyager proved that these forces are real and volatile, and that any mission planning to live out there must be built to endure them. These next-generation spacecraft, now emerging in quiet rooms at NASA and research institutes worldwide, are no longer fiction. They are being drafted with Voyager's legacy etched into their blueprints. Faster, stronger, smarter. They aim to travel 5 times farther than Voyager within half a century, but more importantly, they will carry instruments that can measure what Voyager could only hint at. Instruments that can map the heliosphere in 3 dimensions, chart the interaction between our sun and the galaxy itself, and perhaps, if destiny allows, cross into the true void between stars. And what about our weather satellites? Yes, even they owe a quiet debt to Voyager. By understanding the shape and behavior of the heliosphere, we now grasp how cosmic radiation might fluctuate as solar cycles shift. That matters not just for astronauts, but for the GPS signals, communication relays, and satellites that form the skeleton of modern life. Voyager's whispers inform their protection. What does this mean for us watchers of the sky, listening for the next signal? It means the story is not over. Voyager's discoveries are not relics. They are scaffolding. The mission that began as a planetary tour evolved into a deep space experiment with no precedent, and it left behind not just memories but maps, hidden truths about the edge of our world. Clues are waiting to be read by the next generation of explorers. So, what would you equip it with if you could design the follow-up to Voyager? A fusion-powered engine, or a self-repairing skin? Somewhere, the blueprint is already being drawn, and just beyond the heliopause, the storm waits. Still traveling? There is no applause waiting at the edge of the solar system. No one holds a banner. No beacon flashes in celebration. Only a machine, roughly the size of a small car, continues its journey through a cathedral of nothingness. Voyager 1 now drifts where no human creation has ever gone, past the planets and beyond the Kuiper Belt. It moves through a darkness so complete that even light seems too dim to flow through. This region is not empty, but ancient, filled with plasma waves, magnetic tremors, and the faintest echoes of stars both long dead and not yet born. A cosmic hush that does not respond, only absorbs. Images are no longer part of its offerings. What remains are pulses of data. Gentle, coded whispers traveling billions of kilometers remind us that the probe still listens and speaks, yet most agree that one day it will stop, not with collapse, but with silence. But still, it will travel. To some, Voyager 1 is no longer simply a machine. It has become an artifact, half-engineered relic, half-celestial myth, a frozen memory of 1977 ingenuity drifting far from the noise of our wars, our ambitions, our noise. Out there, in that vast solitude, it holds no context, only inertia. In 40,000 years, if its path remains undisturbed, it will pass near another star. There will be no course correction, no witness, just the continuation of a motion set long ago. So what then is Voyager now? A relic? A ghost? Or the silent ambassador of a species still deciding whether it deserves to be remembered? Perhaps it is all of these things, and maybe that is exactly what it was meant to become. And so while the world tracked Voyager's golden record and cheered its exit beyond the planets, few paused to ask what followed it into the dark. The real story was never about what we sent, but what we received. That cosmic weather was not a footnote, it was a message, and it is growing louder each year. Thank you for staying with us through this hidden current in the heliospheric wind. There is more, always more. But now we turn the mic to you. What do you believe is out there, tugging at the edge of silence? Drop your thoughts below. Ciao.